Okay, here we go. This is the second equation from the previous post. This time though, we have the exponent equations being the same, but the base expressions being different. So we will have to be extra careful now. Firstly though, I'm just going to consider the cases that when the bases are equal, because the exponents are clearly equal to each other already. So here's the deal. I'm just going to say when we have the first to an exponent being equal to the second base to the same exponent, well, this has to be equal to that, right? So that means we just have to put x plus 2 equal to 2x minus 5. Now, I will just have to minus x on both sides and then plus 5 to both sides. So this and that cancel, this and that cancel, and then I get x is equal to 7. And that will do it. All right, so that's the first answer. Now for the next answer, well, if we can make the exponents both being equal to 0, then our job is done as well. So let's have a look for that. So I will say, case 2. I'm going to have a base, the first base, to the 0th power being equal to whatever this is going to be to the 0th power. So that means we just have to look at this, which is x minus 3. We put it equal to 0. Add 3 to both sides, x is equal to 3. So that's the second answer that we have. Next though, can we make the base being equal to -1? Well, let's just do a quick check. Can I make x plus 2 equal to -1? In the meantime, 2x minus 5 being equal to -1. For this right here to happen, we will have to get x is equal to -3. For this to happen, this right here is 2x is equal to 4, x is equal to 2. So impossible, right? And can we make the base both be equal to 1? If I want 1, that means x has to be -1 from here. And that means x has to be 3 from here, different x values. So I cannot have one x value that make the base equal to 1 at the same time. So this is also impossible. So is this it though? Well, in fact, no, because this one I actually didn't get. I had to look at the answer that they have in the original post in order to see it. The last case, I will write it down for you. It's pretty tricky, I will say. I'm going to write it down right here for you guys, like this. Here we have our first base. What we are going to do is that, and in fact, I think this is the reason why case 3 is possible, because the exponents are the same. So if we have the first base right here to an even power, if this is equal to negative of the first base to the same even power, then they are the same. So what do I mean by that though? Well, I'm just going to work it out and then I'm going to show you that this is actually possible. So what I mean by that is I'm going to just put on the first base right here, which is x plus 2, and I will have to make it equal to this right here, negative of the second base. Because I want the second base right here to be the negative of the first, right? Now, if you look at this equation, of course, solve it real quick. X plus 2 equals negative 2x plus 5. And then add 2 to x to both sides, we have 3x. Subtract 2 to both sides, we have 3. And divide 3 to both sides, x is equal to 1. So, why does this work? Because when x is equal to 1, if you plug in here, we are looking at 1 plus 2 raised to the 1 minus 3. That is going to be 3 to the -2, which is 1 over 9. Now, if I plug in 1 into here, we will have 2 times 1 minus 5 raised to the 1 minus 3. This right here is -3, which is what I mean by negative of the first base, right? To the same exponent, but it has to be even. Because if this is negative to an even power, you will also get positive. This right here gives you 1 over -3 squared, which is also 1 over 9. Same thing like this. And In fact, I didn't know about that one. I had to think about it a little bit and also look at the answer key. So I really don't think there's like a very, very nice way to solve this kind of equations. You just have to break down into cases, and there are just many possibilities that you may have to consider. Yeah, be careful with all these equations.